Okay, so quadratic standard form. It is important, especially so on word problems. So you got ax squared plus b. Why did I put y? Bx, sorry. It should be bx. I don't know why I put y there. Ax squared plus bx plus c. So you've got those word problems. And we know that a tells us what? What does a tell us? What does that a tell us? Yeah. You what? Well, there is right. There can be a 1 in front of it. What does it tell us about the graph? So I'm looking for it. So we should know. It opens up or down. So if A is positive, it opens up, which means, oh, this is something. I had some of you didn't even know what a minimum or a maximum was. Didn't tell me that part. If A is negative, it opens down, which means it has a maximum. Pretty important when you're talking about real world problems, when you have a low point or when you have a high point. The other important part in the equation is C. What does that represent? A couple of ways we can say it. The y-intercept, Shelby said both of them. It's the y-intercept where it crosses the y-axis, but in word problems is known as the starting point. Okay, so we're talking about real world problems. What we're going to be working with in this packet, actually the next 3 days. So on that paper, let's see, 1413, what does a dog do that a man sticks in? So, up there in that little box, it says following stuff, and you may have seen some of these equations if you've taken physical science maybe. It says suppose an object is dropped and gravity is the only force acting on it. The height 8 of an object in feet is modeled by, so the height h modeled in feet is negative 16t squared plus c. And it says where t is the time since the object was dropped in seconds, c is the initial height of the object in feet. And that's completely ignoring air resistance. So, the clumsy eagle. First problem there. An eagle soaring over a river drops a stick from a height of 400 feet. Complete the table and graph to show how the height of the stick was related to the time since it was dropped. So they tell you, they're defining their variables. Let t equals the time since the stick was dropped, h equals the height of the stick. So you got an eagle, he's flying, and he's how high? 400 feet, right? He's 400 feet high, and he drops the stick. And it said, does your graph show the flight path of the stick as it falls? Does things fall straight down? If you stand on top of a building and drop something, does it drop exactly below where you dropped it? No, it actually comes out in what you would think of a parabola, a part of a parabola. Alright, so they've given you this table over here, and they've given you a graph, so they've helped you out by saying, okay, we're starting with time across the x-axis, so that's our dependent variable, and they've got it in seconds, and height, which is in feet, and what are they counting by? On feet. What are they counting by on feet? Counting by 50s. That one's 50, that one's 50, that one's 50. What are they counting by here? Counting by 1. So they're counting by seconds and counting by feet over here. Alright, so you've got the table. And time in seconds. Feet is the height. So they're telling you they want you to fill in this table. And they just said down at the bottom, well actually I wrote it right here, here's your equation. But we've got to fill in one thing. We've got to fill in C. So what's C? Where does it start from? 400 feet. Because it says in the problem, an eagle soaring over a river drops a stick from a height of 400 feet. So at the initial time he drops it, it's at 400 feet. Okay, so 0, 400. Because if we write this, our equation, h sub t is negative 16t squared plus 400. Why is a negative? What's happening to the stick? It's falling down, right? A is negative because it's falling down. It starts at 400. Alright, so let's go to our calculators and put in negative 16x squared. You're not putting in t squared. Negative 16x squared plus 400. Now we definitely do not want to graph this on the standard viewing window. Because the standard viewing window only goes from 10 or negative 10 to 10, right? They actually gave us what they wanted us to use in the table. They want your, why do we not need to see negative x's? Why are we only graphing the first quadrant? Do what, Sam? Can't do a negative what? I can't fall a negative distance. And I can't go back in time. So the only problem, we're only graphing this first quadrant. So we don't need to see the rest of it. So they're saying, hey, here's your lowest x, here's your highest x, here's your lowest y, here's your highest y. I want you to count by ones on the x. I want you to count by 50s on the y. Now the only thing, when we go to our window though, so you're going to go to window. Okay, we're going to go to window, and we're going to change it. But we don't want our x minimum to be 0. We want to see a little bit past it. Okay, so I'm just going to make that one negative 2. I don't know. And my x maximum, well, what was my x maximum here? 5, but I want to go past that, so let's just go to, I don't know, well, let's go to 7. And the scale, what are we counting by? Counting by ones. Okay, so the y minimum, what was our lowest y? 0, but we want to go a little bit below that. So if we're counting by 50s, let's just go down to negative 50. So we're going to go to, whoops, let me put in 1 there. All right, so we're going to go to negative 50 on the y. What was our highest y on our table? 400. So let's go above that. So let's go to 450. And what were we counting by? 50s. Don't worry about the resolution. Don't worry about this delta x. The only thing you're worried about are these things right here. The x minimum, x max, x scale, y minimum, y max, y scale. And if they give you a graph already, fix your window to fit that graph. So when we hit graph, see something like that. Okay, so this represents the eagle he's up here flying. How high is that eagle right there? 400 feet. And what happens when he drops the stick? It falls. And then what does that point right there represent? When it hits the ground, right? Yeah? Okay, so let's fill in our table. So second table. There's your points. Fill in your table. So fill in your table right now. So you've got 0, 400, 1 at 384, 2 at negative 336, 3 at 256, 4 at 144, and all of a sudden it's 0. So your table should look just like mine. So 384, 236. Alright, so we got our table. So let's think about, what does this table tell us? So it starts out at 400 feet high, right? How far does it fall in the first second? What's 400 minus 384? 16. So it falls 16 feet in the first second, right? How far does it fall in the second? From second 1 to second 2. 384 minus 336. Got your calculators. So 384 minus 336. What do we get? 48. Okay, so it fell 48 feet then. What about from here to here? 80, I think. 80. So it fell 80 feet from here to here. 112, and from here to here, 144. What's happening the longer it falls? It's falling at a faster rate, isn't it? Which makes sense. You're falling at a faster rate. All right, now, if we graph those points, so let's graph them. You have to kind of guesstimate in here. So we got 0, 400. We already had that. 1, 384, 2, 336, 3, 256, 4, 144, and 5, 0. And connect those. Well, oops. There we go. So does that path simulate the path of the stick as it falls? Yeah, that's what's happening. How long does it take for that stick to hit the ground? 5 seconds. That's also called a what? An x-intercept, right? That point right there, which is also right there, is the x-intercept. What else do we call it? Root, 0, or the solution. And that's all it asks us to do on that. Okay, number 2, or whatever, I guess. It doesn't say number 2. A skydiver jumps from a plane at an elevation of 12,000 feet. He waits 24 seconds before opening his parachute. I don't know that I could wait 24 seconds, but complete a table and graph to show how the height of the skydiver varies with the time since he jumped. Alright, so are we using the same equation?
Yes.
Almost. What's going to change in our equation? C's going to change. What's C going to be this time? 12,000. C's going to be 12,000. Alright, so we got h of t equals negative 16t squared plus 12,000. So this time, what are we counting by on the x's? Counting by 3's this time. This is the time in seconds, the h and the again. So go ahead and graph, put that equation in there. Is this counting by ones right here? Is this y-axis counting by ones? What's it counting by? thousands. Look in that, I wrote it, intentionally didn't write it up here. What does it say right there? Thousands of feet. So it's really counting by thousands. So when you go to your chart, you type in negative 16x squared plus 12,000. Whoops. We got to change that window first, because we're still back on that window where we only see the 400. So our x minimum, is it okay to leave it at negative 2? We want to see a little bit past 0, so that one's okay. But what's our x maximum this time? Our largest one is 24. But we want to go past that a little bit, so what do we want it to be? 27, okay, that sounds good. So 27. And we're counting by threes. Counting by threes on our scale. All right, y minimum is negative 50, okay? Yeah, I mean, it's okay. All right, what's our y maximum? What's the largest we want to see up here? Do we need to put in 12,000? Or can I just use it as 12, knowing that these are counting by thousands? We can just use it as 12, can't we? Knowing that we're counting by thousands? Or you can put in 12,000. Totally up to you. I would leave it just like what it has up there, and I would put my y maximum probably at 15. Knowing that on my y's, I'm counting by thousands. Now my scale is still going to be ones though, because we're counting by ones if you look at that table. Now if you want to change that, you can put 15,000 here and make it counting by thousands if you want to do that. Totally up to you. It's going to look the same. So when we graph, what did I do wrong? What would happen here? First thing I should do is check my what? The equation. Check my equation, see if I typed it in there right. Negative 16x squared plus 12,000. Is that the correct equation? Okay, so if I go to my window, what's going on here? If I put, here's where you got to make the mistake, you got to think about it. If I put 12,000 in here, do I not want my window to be also in thousands? Probably so. Now, if I wanted it to look like this, what should I change my equation to? 12. So what I would, yeah. Alright, we'll fix it in a minute. Alright, so on my window, I'm going to go back down here, and I did that just to show you, do I really want that to be negative 50? Because I'm going to go down here and I'm going to count by thousands. And I'm going to make this one 15,000, but I did that on purpose just to show you, here's what we got to do. Does it matter if it's negative 50? I mean, just graph it and see. Does it matter if it's negative 50? Can I see any of that bottom part? Can't see a whole lot of it, so I probably want to change it. Can I see anything past here where I want to see it? Can't really see anything past there, so I want to lower my minimum, my y minimum, and I want to increase that x maximum. So because I want to see the whole graph. And a lot of this is just changing things just to see. So x maximum, we put it at 27. What do you think? 30 maybe? I mean, it's just a guessing game. My y minimum, let's make it negative 1,000. Since we're counting by thousands, see if that helps us look at it any better. Can we see it a little better? Yeah. Alright, so now, fill in your chart. So go to your table. So second table. And the first ones are in the table pretty easy, aren't they? You can see them. 3 is 11,856. 6 is 11,424. How do I see the rest of them? I could look at, I can go down through here and scroll down until I get to 24, 21, all those. What's another way I can do it though? If I want to find a specific x value, what do I need to do? How do I find a specific x value? Second, calculate. Number one, a value. So instead of using that table, if I want to say, all right, what's x when it's 24? There it gives it to me. So instead of scrolling up and down my table, I can type it in. So 2,784, I can say second, calculate a value number one at 21, because that was another one. And there it is, 4,944. So go ahead and fill in that chart there. So what is, at 0 seconds, the guy's at 12,000 feet. Where is he at 3 seconds? 11,156. Anybody else get that?
I got 8.
Did I hear it wrong? 11,856? I may have heard it wrong. 11,856? What about 6 seconds? 11,424? 9 seconds? 10,704? All right, 12 seconds?
9,696.
696? 15?
8,400.
400? 18? What?
6,816.
6816?
Yes.
21 I just did. What was it?
49.24.
And 24?
784.
2784. So all you're doing is just looking at your table. If we graph it, of course you're going to have to guess at a lot of these estimating. So 0, 12. Doesn't fall very fast at first, does he? Let's see, 11. You got your graph here. What's the problem with this graph? It didn't go all the way down, does it? Could we extend it on out? We could, to find where he crosses. But if they didn't ask us that, then we don't have to. Alright, so 7. Galileo dropped a cannonball from the top of the leaning tower of Pisa. Alright, Galileo dropped a cannonball from the leaning tower of Pisa, which is 185 feet above the ground. How long did it take for the cannonball to hit the ground? So what's our equation going to be? When we type it in there, what's it going to be? Y equals what? Negative 16x squared? Plus 185. So negative 16x squared plus 185. And we graph it. Now we'd have to change our window, right? If I just hit graph right now, would I still see it? Well, yeah, there it is. Doesn't look too good, does it? Because we're counting by thousands right here. So what do we really want to count by? Well, our top one was 185, right? So, I mean, do I need to change my X? Do I need to see all the way out to 30 and count by threes? No, so maybe if I go to like 10 and count by ones. So So if I change my window to maybe go to 10 and count by ones, do I need to count by thousands on this Y? I don't need to count by thousands, do I? I certainly don't need to go to negative 1,000. So I need to widen that one out. So if I just make that whatever, negative 10, let's say. And our Y maximum, well, he dropped it from 185 feet, so we don't need to go above 185, do we? So what do you want to start at? Do what? Well, no, he's got to be at 185. 190? How about we go with 200? Okay, but where do we want to start? We don't start at 0, right? So does it matter if we leave it at negative 10? Doesn't really. Let's just try and see. So, wait a minute, Y max. Let's just say 200. I don't even know what I said before. Let's count by, what, maybe 10? Just to see. Alright, so there he is dropping his cannonball. Yours may not look exactly like that. It doesn't matter as long as you can see this point and this point. You clear? Okay. Alright, so we're starting at this point and this point. So it says, how long did it take for it to hit the ground? So we want to know that point right there. What is that point called? An x-intercept. How did we find the x-intercept? What did we, nobody's leaving yet. What did we put in our y2? 0. That's where we're going to start tomorrow. 0.